coming up on Bronco Tales.
And we're just beginning to understand like the brain and, its interaction with the environment, control of our bodies, all these things. And I mean, if you took the neurons from your brain and lined them up end to end, you could go around the earth 4 times.
Oh my gosh. In this episode, we'll be exploring the dynamic interplay between kinesiology and neurology, 2 fields at the forefront of understanding human movement and brain function. Join us as we unravel the intricate relationship between physical activity, exercise science, and neurological processes. Our esteemed guest, Bob Wood, will guide us through compelling conversations, delving into the neurological basis of movement, the impact of neurological disorders on physical function, and the potential of kinesiology to enhance rehabilitation. We'll explore groundbreaking research, innovative technologies, and collaborative efforts between these disciplines, shedding light on how movement science can contribute to improved brain health and cognition. Whether you're a scholar, a healthcare professional, or simply curious about the fascinating realms of kinesiology and neurology, this podcast promises to be an enlightening journey into the future of understanding human movement and the brain. My name is Anastasia Tracy, and I'll be the host of today's podcast. I work at Boise State in medical imaging, so I'm definitely not a kinesiology expert, so I'm going to defer all those questions to our expert, Bob Wood. Would you go ahead and introduce yourself and tell us a little bit about the field of kinesiology and what sparked your interest in it?
Yeah, thank you for having me. I grew up in upstate New York, and when I went to college there, I was very interested in sport and these kinds of things. So it was a real kind of natural inclination for me to pursue physical education as well as biology. And so I was double majoring in these areas before kinesiology was even a degree at most institutions. So I was kind of putting it together way back in the 80s when I was in college. And then from there, I went to graduate school at LSU. And I became kind of interested in aging and chronic disease and the impact that aging and disease have on our autonomic nervous system, which is that part of the nervous system that controls our organs. It isn't stuff that we have to think about to do, but it can maintains our internal, we call it homeostasis, right? So, but it maintains normal functioning of the body. And I was very interested in particular in the control of the heart and cardiovascular system. And so this is what I did my dissertation studies. My work was in that area. And from there, I became a little more interested in the functional aspects of aging. So not just how does the autonomic nervous system age, how does the cardiovascular system age, but what are the implications for longevity, for functional lifespan, and those kinds of things. And that's where I did most of my research. And after, I don't know, about maybe 10 years of being heavily immersed in research, I decided to get into administration. So for about the last 15 years almost, I've been not really in the lab as much as I am trying to support other faculty who are trying to move their research forward.
Awesome. So you've been at Boise State for how long?
I've been here 5 years now.
Perfect.
Yeah.
Compared to other institutions, how is our kinesiology program compared to maybe others? And you don't have to use specific school names. We're not trying to bash anybody.
I think the areas of strength of our program have historically been in athletic training and strength and conditioning. Yeah. Our athletic training students typically do very well in national competitions, and they get really good jobs. And so most people, when you talk about Boise State, they say, oh, athletic training, sort of like they talk about the blue field, right? And so as we're growing now, we're moving into other areas of like health, disease prevention, primary prevention, secondary prevention, particularly conditions and diseases like obesity, diabetes, metabolic syndrome, cardiovascular disease, where we don't have as strong a history as other schools may have had. We're moving into those areas pretty rapidly now.
Interesting.
Mm-hmm.
So, I mean, you just touched on a lot of different areas within the realm of kinesiology that I think a lot of students don't necessarily even understand, like not just other people are like, oh, Boise State's athletic training program, not our kinesiology type programs. I think you just hit the head on the nail by describing a bunch of different avenues that students may not know fell under that umbrella. So what makes a good kinesiology student? I mean, you just highlighted your interest in some not necessarily the most exciting or readily available studied fields that got you into the field that students may not have known they had an interest in. So what makes for a good kinesiology student?
Yeah, I honestly think that the thing that I would advise students to do is to take opportunities to create sort of a unique experience for themselves. Many students are wanting to go into, professional programs, PTOT, these things, physician assistant school, these things. And some are going to go directly into like wellness industry. But in any case, I think the key is how do you make yourself different from the next person, right? And there are some ways that are really helpful for students. One is to, find a faculty member that you really like, that you feel you connect with, and you value the work that they do. You like the work that they do. It interests you, and volunteer. See if you can help in the lab. Maybe that turns into a student worker job even. And really push yourself to achieve whatever you can in those unique ways that you're trying to develop yourself. Other things, maybe leadership roles, like in joining student organizations. Maybe you're not really interested in research, but you're interested in leadership and those kinds of things. So pursue that, or pursue opportunities that are unique in educational opportunities, like study abroad. Right? I think at the undergraduate level, you want to try to just create a story that is both unique, meaningful to you, and will resonate with others who you wish to help.
I love that. I think those are great tips specific to kinesiology students, but I think they're great tips relative to most students in general. Getting a degree is great. Making yourself marketable is way better.
Yeah.
Okay, let's get into the meat of kinesiology a little bit. So in your own words, like maybe away from the definition of our classic textbooks, define kinesiology for me.
Well, it's a little hard to get away from the classic definition because I actually agree with it. It's essentially the study of human movement.
Right.
And so I think what we see is that's such a broad area that it requires people have to kind of define what it is within that field that they want to specialize in. But I think it's also important for people to see how all of it's connected. Like, how is biomechanics connected to cardiovascular physiology? How is it connected to physical education or historical and social study of human movement? In all of these areas. Dance is another one that I think is just an amazing area of work, and it all fits under the umbrella of kinesiology.
Absolutely. Let's gear this a little bit more toward the ways that kinesiology has changed with technology. Like, how have you seen the just over time? Like, obviously, you've been in this field for quite some time. How has studying the field of kinesiology changed as a result of advancements in tech?
Yeah, well, obviously, probably the biggest thing is, the human genome, right? And our understanding of not just genetics, but epigenetics, because a lot of what we do in kinesiology is intended to, deploy physical activity or understand physical activity as a treatment strategy for prevention of diseases, for prolonging functional lifespan. And really, so what we're talking about is, how does the environment in which one lives and the behaviors in which they engage, how does that interact with their genetics in order to, achieve a high quality of life with respect to those, disease prevention and those kinds of things. So that's probably the biggest thing. But obviously, the opportunity for us to, measure, physiological phenomena is, just incredible. We're able to do so much with understanding, for example, like through use of MRI and NIFR, looking at brain activation, and through some non-invasive means using like sonography, as you understand. We're able to understand human physiology and the impact of treatment strategies. Also, unfortunately, the impact of not being physically active. Right. So, it's too bad that being inactive is the control. It would be nice if being active was the control. That was the standard. So I think being, there's myriad ways that we can assess some of the phenomena that we're interested in. I do think because of the way things are moving, there's a greater demand for transdisciplinary work. Multidisciplinary is great. That's where you have several people studying the same group at the same time, but for different questions. Interdisciplinary is great, where you are asking questions that you need each other's data for. And then transdisciplinary is where you're basically creating theoretical frameworks, testing theoretical frameworks that require multiple disciplines that are embedded in that theoretical framework. So I think the move towards trans theoretical framework is very, very important. And then the other piece that I think is happening that we really need to be thinking about is that our work is really global. That, we think about oftentimes in instruction, like, well, how can we add this to our program? How can we add this to our program? Well, perhaps the way we add that is by having a foreign exchange opportunity for students to go study it with our friends over in Spain or Germany or Lithuania or Portugal or Brazil, right? Why can't we do it globally? And I think technology has afforded us a lot of opportunities in that regard. So whether we're talking about, understanding the impact of activity and disease, whether we're talking about being able to measure functionally what's going on as a result, or whether we're talking about like how do we take advantage of a global community to strengthen our advancement of knowledge, I think there's just a ton of things going on right now, and that I'd like to see us kind of take advantage of.
Yeah. Well, I mean, boots on the ground for an opportunity to, be on site researching some of these areas would be really great opportunities for students. And again, really great ways to set yourself apart. How do you, and this is again a personal question more than it is like a research-based question, how do you feel by comparing populations relative to the study of kinesiology and to the access of technology in certain areas, like I'm trying to figure out the best way to phrase this question. Do you believe that there is vast difference really between populations and their approach to health relative to kinesiology, also access to technology relative to the health and ability to study kinesiology? Yeah,
there's a lot of what I would call, you can use a couple different phrases, but social determinants of health that are certainly impact the study of human movement and how we think about it and how we approach it. And then also health disparities that might emerge as a result of those social determinants of health, right? And so, different, for example, different cultures even take physical activity to mean a different thing. Right. There are some cultures that the phrase physical activity actually means sexual activity.
Right.
And so, we have to arrive at a common language first, but then we have to understand culturally, for example, there are some behaviors that are not even physical activity, where it is not viewed as an important or attractive or proper type of thing for example, in some cultures, for a young lady to engage in that. And it wasn't that different in the United States that long ago,
Right.
Where 100 years ago, riding a bicycle was seen as sexually promiscuous activity, right?
How dare you?
So we have come a long way, but not every culture is moving forward at the same speed. There are some cultures where it's difficult for women to exercise because they have to cover themselves. These are some of the things, and I'm sure there's a million examples, but those hopefully kind of bring it to the forefront of someone's mind. Like, oh yeah, it's not necessarily the same everywhere. And this has impacts public health and from a global perspective.
Yeah, it's interesting thinking about that. Like, of course, there are cultural differences that contribute to, lifting culture, going for a walk every day, or not doing any of the above, right?
Yeah, and well, in our country, I would say one of the cultural problems we have is the expectation for young women, especially teens and, adolescent girls, to look a certain way.
Yep. Thank you, social media.
Yeah, and this impacts their willingness to engage in activities that might not support looking the way they think they're supposed to look. So that's one example. And then you have, guys on the other side of the coin who perhaps are valued for physical prowess, perhaps to an extent that maybe, the pendulum's a little too far the other direction, right? And so what's the healthy approach, right? Yeah.
Yeah, that's interesting to think about. I think that guys kind of drew the short straw when it comes to societal standards, right? We talk a lot about how women are affected by social media and how we build our bodies surrounding the appearances that we think we're supposed to. We hardly talk about how men are influenced by those exact same, set of standards.
Yeah.
So anyway, interesting little tangent. I'm going to shift our wheel a little bit more toward the brain and the effects of the brain on the ability to participate in some of these exercises. Like, it's not obviously just limited by cultures, it's limited by physical capability of the autonomic nervous system.
Yeah, there's a lot of work going on in this right now. Of course, there just very generally, there's a lot of depression and anxiety that is, kind of impacting our youth and young adults, really all adults, to be quite honest. But this has, we aren't entirely sure the impact of this on behavior choices, but we do know that, coping strategies often involve things more like drugs and alcohol as opposed to physical activity. But in many cases, whether it's somewhat viewed as a healthy coping strategy or an unhealthy coping strategy, we see that people are quite frequently self-medicating through the behaviors that they're choosing in which to engage, and that's not ideal either, right? So, trying to work with youth and athletes, there's a lot of other things that we're trying to explore. One is how we recover from things like injuries, not just head injuries, but all injuries. Of course, head injuries is really prominent area of study, and it's also one that's affected politically, right? It's kind of difficult to explore some of these questions because people are afraid of what they're going to hear or what we're going to find out, or that's the kind of news they don't want to hear, either as a patient or maybe a coach or a school or whatever. So it's really challenging to kind of uncover. And we've seen this in some of the documentaries around football players and these kinds of things. It becomes a little bit politically challenged. But we often see that people change the way they actually recruit their limbs after they've been injured. Like they changed, and we look at their brain, we see a different recruitment pattern. For example, if an athlete has an injured, let's say they injured their left knee and they have an ACL tear and they have surgery and all of this, and then we get in a lab in a controlled trial or a controlled environment, and we say, okay, do some leg extensions with your unaffected leg, and we look at brain activity, and then we do some leg extensions with the affected leg, and we see a very different brain pattern. And this may be explaining why people, especially if they come back too soon from an injury, they're more susceptible to further injury. And we even see this also with head injuries too, that people that come back too soon from a head injury are actually more likely to be injured in other ways on the field. So this is an interesting area that people are exploring. There's been a lot of data now on college age and professional athletes. So it's not quite as hot, but we have to understand youth better, because the young person's brain is not fully developed. And if somebody has a head injury before about the age of 21, it's really super important that they fully recover before putting themselves out on the playing field again, because if they get something called second impact syndrome, it can be devastating. It can, be paralyzing. It could kill them. It's just really important. And there's not a lot of evidence. There's still a great need for head injury in youth as an area of investigation. So that's one of the areas we're trying to be productive in here now at Boise State. We've got a couple really talented faculty working in this area. So kind of from a global perspective, that's some of what kinesiology is interested in. But we also, when we look at things like aging and chronic disease and things like Alzheimer's and Parkinson's and dementia, there have been for many years anecdotal evidence about, well, if you stay active, you're gonna maintain your cognitive ability longer than other people. Sure. But what the evidence is showing now is sort of this epigenetic question, right? It's like, well, if you have a certain genetic code, then you are going to be at risk for dementia. And for those people with a certain particular genetic code, exercise does demonstrate that there's a protective benefit against cognitive decline. So there's a gene ApoE that has different forms. And if you have the ApoE4, if you're heterozygous for that, then physical activity shows a modest benefit in terms of protecting any cognitive decline. But if you're homozygous for it, both alleles, then it shows a tremendous benefits. So there's a dose response there that makes us to think, this is really important. So people with ApoE4, whether heterozygous or homozygous, it's really important for them to be physically active. So we are figuring out sort of like we believe physical activity is important for everybody, but as related to, is there a protective effect against cognitive decline? We're kind of sorting that out as to why. Some people can live for 95 and, eat egg, bacon, and eggs every day and smoke and drink, and they're fine, right? And they just go to sleep one night and they die. And other people, at age 50 and 55, we see signs of dementia who were taking care of themselves. And so, so we're sort of figuring that out through what we call a study of epigenetics, which is how does really behavior, exposure, and environment to things, how does that change the phenotype or how one's genotype is expressed functionally? Right. Yeah.
Again, I'm going to change gears a little bit, but in a similar vein, we've talked a lot about, conditions that are quasi in our control, right? I mean, if it's football, right, we can, of course, choose not to play football and, lower our risk of concussion, right? Yeah. Aging might be a little bit out of our control, but healthy aging is more so in our control, right, relative to exercise, nutrition, those things that we know are good for us. So I want to gear us more toward things that are out of our control. What about some of the diseases that, people are born with and how they are relative to kinesiology? Is there a lot of research in those veins as well?
Yeah, I mean, there are some. One of the areas that kinesiologists have been very interested in is muscular dystrophy.
Yeah.
And some of these other, similar related neurologic deficits. I think the work in kinesiology has helped us to better understand the disease. But obviously many of these are progressive and, chronic progressive diseases. Cystic fibrosis is another one where, physical activity has helped us to try to better, or kinesiology studies have helped us to better understand, what role physical activity might play. There's really not, I don't think there's a lot of evidence to support physical activity as a treatment strategy for some of these things. But certainly the evidence is compelling that in any case, these people that have physically limiting diseases that are progressive, is that exercise and physical activity can very potentially slow the demise, can slow, so we don't always see, it's kind of like another one that's not, depending on the pulmonary disease, like if someone has a chronic obstructive pulmonary disease, then they're going to get worse. Right. But how quickly do they get worse is the question. And we do see that there has been some work in these types of areas to show that physical activity and exercise can slow the progression, improve the prognosis in that respect, and kind of delay like mortality due to that disease and morbidity. So yeah, as far as like the sort of congenital or genetic anomalies, it's I don't know that there's a lot of evidence in that area, but some of these kind of chronic diseases that people acquire, there's probably a little more in that area. Yeah. Yeah, diabetes is one that can be genetic. Maybe this is a good area, right, to talk about, right? So, your type 1 diabetics, exercise is proven to be really helpful for them. Obviously, they're not going to start making insulin if they start exercising.
That's not how your pancreas works.
Right. But we do see that these people enjoy the benefits of exercise and can compete, very competitively. There's been a lot of work looking at how do you manage your blood glucoses as a competitive athlete? How do you enjoy those things? And so in terms of like quality of life, there's a lot that the field has done to help support these. Some type 2 diabetics, they're going to be type 2 diabetics no matter whether they ate well or were physically active. But then there are also a lot of type 2 diabetics that are type 2 diabetics because they did not take care of themselves. And so, but in any case, physical activity and exercise is really helpful in, getting people back into good blood glucose management, glucose tolerance, insulin sensitivity, all those things that we look at. The problem is the people that have type 2 diabetes because they did not, choose good health behaviors in the first place, it's not easy to get them to now choose healthy lifestyles.
Oh, is it hard to break habits too?
Yeah, so there's actually a lot of work in our field too around behavior change. It's not just about how do cells respond, how does, your, cardiovascular system improve. There's also, and it fits into the neuroscience and into the brain, is, what type of strategies are going to be most effective in changing behavior.
It's really interesting. I think it's so easy for me in the realm of medical imaging where we stare at the brain all day, right? For me to just think of the brain as this, orchestrator of organ function, and rather I kind of skip the side of behavior because it does feel so readily able to be changed, even though that's not necessarily the case for many circumstances. And so seeing that interplay between kinesiology, medical imaging, we could even bring nursing and every other realm of healthcare into this discussion because, like you said, transdisciplinary research is pretty critical in this area.
Changing people's minds is not so easy.
No, not exactly. Well, I think we're getting pretty close to time.
Okay.
So I was hoping if there's anything more that you want to add, just kind of as closing thoughts for this podcast?
So who's our target audience? Students.
Just in general.
Yeah, well, I think one of the things we wanted maybe out of the podcast was to talk about what's happening more broadly with neuroscience.
Yeah.
And so, neuroscience is just a crazy field, right? It's just exploding, and we're just beginning to understand like the brain and, its interaction with the environment, control of our bodies, all these things. And I mean, if you took the neurons from your brain and lined them up end to end, you could go around the earth 4 times.
Oh my gosh.
Yeah. 100,000 miles of neurons in your brain.
That's crazy.
Right? So, and it has applications for so many areas. It has applications for understanding human behavior, as we've talked about. We see epidemics of depression, anxiety. We're now seeing where, for example, on the medical boards now, there's a psychology and sociology, social sciences section on the medical boards.
Yeah.
And that's new because they're insisting that people have foundational understanding of human behavior and how the biological basis for behavior. And then we also have on the other end, cellular and molecular studies of, we talk about like long COVID, and we're discovering how that affects oxidative metabolism and why that therefore is, creating problems with like neurologic function and, why the impact on the nervous system. And we're beginning to understand those things through some of our cellular molecular studies. And then we have the rehabilitation piece, right? Where a lot of people in kines, that's why they get into kines, is the physical rehabilitation, whether it's primary prevention or secondary prevention, right? So maybe we call it prehabilitation for the primary prevention people and secondary, tertiary prevention for those in PT and OT. And you think ultimately our goal is to keep moving, right? We would all like to live to be 95 and in a healthy, active life and then die in our sleep, right? And so how do we best achieve that? And there's no single, medicine that there's no even combination of, there's no single strategy that is greater impact on our health and longevity and functional lifespan than exercise and physical activity. And so understanding why that is and how do we best utilize physical activity and exercise as a treatment strategy, these are the things that the kines folks are typically interested in, but it's all neuroscience, and how do we get people to adopt those behaviors? It's neuroscience. How do you get people to change their mind? It's neuroscience. How do you get your partner to see an issue a different way? It's neuroscience. How do you get your parents to approve you doing something that they previously wouldn't? It's neuroscience.
That's the truth.
So I think it's really, and we see a very neurodiverse community now where we're seeing more and more people with what had previously kind of been, conditions like autistic, the autistic spectrum diseases or conditions rather, that they were not, able to work. And now we see that the workplace, there's a lot of neurodiversity.
Yes.
And, and understanding how to create spaces, how to work with people, how to work across the table with people in your lab.
Right.
Who, are not, they're neurodiverse, right? And so, it's just the world is becoming a place where neuroscience is just, it's becoming everything. Honestly, just personal anecdote, I have a shoe problem. And if I look
the best shoes.
If I look at a pair of shoes online, my next 10 emails and Facebook posts and that I'm going to see are shoes. That's neuroscience.
Yeah. Micro-marketing.
Google loves hiring people that are neuroscientists. Yep. So I think, that's why people are kind of flocking to that area. It's really a way where people can find a myriad of things they enjoy.
It's obviously an interesting field, and I appreciate you taking the time to talk with us today. If students potentially wanted to reach out to you, would you be comfortable with that?
Oh yeah, it's pretty easy. Bob Wood.
Yep.
At Boise State.
Exactly.
.edu. So.
Perfect.
Yep.
And I think that is all I've got for you.
Okay. Great. Well, this was fun.
This was fun. I feel like I learned a lot.
Yeah. Thanks for setting this up. And yeah, students, please come visit.
Yeah,
might as well. Love to talk with you.
Thank you for listening to the Bronco Tales podcast. On next month's episode, faculty from our respiratory care department will break down exactly what it means to be a respiratory therapist. We'll see you then.
In our on-campus program, which I'm the program director for, we prepare students to sit and take their licensure board exams. Our program is 2.5 years or 5 semesters. And during those 5 semesters, students learn what it takes to be a respiratory therapist.